limited targets, it wouldn't be fair. Okay, so let's do this one. Now, when you see this, I know this is what, example 5 or 6, I don't know which one we're on. But when you see this, there should be certain things that you're seeing at this point based on the number of examples that we've done. Based on the number of examples that we've seen. Like, for example, you should see these squared values. And squared values mean something, right? Squared values, our radar goes off. Our ears start to perk up about that. So, right away I think this is an option. Okay. Now I also see a minus sign. But the minus sign here is not as obvious as the minus sign that was in, oh gosh, we had to go all the way back, as the minus sign that was here, where we had common terms that we could factor out. Okay? So this minus sign that we're looking at just has these two things separated. There's nothing there that I'm going to try to factor out. So even though there is a minus sign, I'm not going to do that. There are no fractions. And these three tools all talk about fractions right now. I'm not going to factor by grouping because I need 4 terms in order to do that. Now, that leaves me with one of these two tools. Show of hands. At least show me your hand. Did you do one of these two things? Did you try them? One person, 2? Okay. Some brave souls out there. Thanks. Limited audience participation is okay. So now when we look at this, we have squared terms. So let's go that route. Now we haven't talked about this bad boy yet. Right? Our squared terms were always sine squared or cosine squared. But we have a Pythagorean identity that looks like this. Can I manipulate this Pythagorean identity to fit here? Is there something I can do to end up with secant squared x minus 1? Alright, and I'm going to see, let me check the camera angle here to see if I can do my margin work. Ooh, yeah, I think we can get away with this. Alright, so I want a statement that says secant squared x minus 1. This is how the Pythagorean identity sets up. How do I get this to say secant squared x minus 1? Well, I subtract the 1 over to the other side. So tangent squared x, which is left over here after I get rid of that, is equal to secant squared x minus 1. So here it is. That's that. So I'm going to cut that out, and in its place, I'm going to put this. Now, one thing we haven't talked about is that cosecant squared x. You're like, that's a squared term too. And I know there's a Pythagorean identity for cosecant squared too. One step at a time. One step at a time. Okay? Because here's, and I'm going to speak philosophically for a second. When we're asked to simplify, stay with me now. We just took 2 terms and replaced it with 1 term. That's a win. That's a good solid step to take. The Pythagorean identity that involves cosecant squared looks like this. So the way that this one's set up, I don't even need to manipulate this. I could just say, well, if cosecant squared is equal to that, I'm going to put it there. You could. That is an option. There's no manipulation involved. It's just cutting that out and putting that in its place. The one thing I will say, and again, it's not wrong to do that, but the one thing that I will say is, we just got to here, which is pretty simple compared to that. Why would we want to bring two more terms into this expression when we have one? Right? This was a win, getting rid of two terms and putting one in its place. Okay? Now again, could this be done? Yes. Do I want to do that? Let's hold off for a second. Let's look at this. Okay? Now, we come back to the toolbox. Tangent and cosecant have no relationship between them. You could look at all of the identities that we have. All of the Pythagorean identities, all of the reciprocal identities, all of the cofunction identities. Everything that we've looked at prior to this, tangent and cosecant have nothing in common. Except for the fact that they can be written in terms of sines and cosines. So why don't we try using that tool and see what it gets us? One thing worth noting, come off to the side here for this, okay? Somewhere in your notes you have this statement, tangent x equals sine x over cosine x. Somewhere in your notes you have that. It would have been from Tuesday? Maybe Wednesday? Wednesday. Okay? So if you watched that video or if you were here in class that day, you guys were here in class that day. Okay? So you should have this in your notes. This is true. So is this. If I want to square the tangent, I can. I square the sines and cosines as well. So tangent in terms of sine and cosine looks like this. Tangent squared looks like that. So that's what I'm going to write here. And the same thing can be said for cosecant. Okay, again, over in the margins here. We know that cosecant x is 1 over sine x. That's in your notes, or should be. So if cosecant is 1 over sine, cosecant squared can be 1 over sine squared. So that's what I'm going to write in here. So we manipulated and substituted the squared term using a Pythagorean identity. Then we wrote everything in terms of sine and cosine. And at this point, seeing this for the second or third time now, when we multiply these two fractions together, we can cancel on the diagonal, we can cross cancel. So the sine squareds that are here cancel out. And on the top we have a 1, and on the bottom we have a cosine squared, which is pretty simple compared to what we started with. But we can make it even just a little bit simpler, right? If cosecant is 1 over sine, and cosecant squared is 1 over sine squared, what is 1 over cosine squared? Right? We have that identity. I mentioned from the beginning of this that you don't have to memorize all of the identities. I don't expect you to memorize them, okay? But I expect you to recognize them. Like 1 over cosine is in your notes. You have an equivalent statement in your notes that says secant x is equal to 1 over cosine. I expect you to at least recognize that 1 over cosine has an equivalent statement. And if you're like, I can't remember if it's cotangent or tangent, but I know I've seen it before, go find it. Okay? Because 1 over cosine squared then is equal to secant squared. Right? Which is even simpler than having this fraction. Okay?